In this lesson, we are going to be beginning the exploration of quadratic relations, which are also quadratic functions, and we're going to be looking at the relationship of them and what they look like. Some previous experience that you may have is linear relationships. We have graphed lines before, but what we're going to look at in this particular unit is graphing quadratic functions. So the first question is defining a quadratic function. There's many forms of a quadratic function. The first one we're going to investigate is a standard form. The standard form of a quadratic function is right here. Is y is equal to, in red, a times x squared plus b times x plus c. And that's where a is not equal to 0. Because if a was 0, it would no longer be a quadratic. In other words, there are no brackets and there is a squared term. So in standard form, there are no brackets, and there's a term that definitely has a squared on it. Let me just introduce the quadratic functions to you by just showing you some graphs. So you'll see here, this is just a particular graphing website. You'll see here, here's the function y is equal to x squared plus 2x minus 2. So there's no brackets there, and there is a squared term. Here's what that function looks like. Now if I start to just get rid of some things, so here is the function y is equal to x squared plus 2x. You may want to direct your attention over here. I'm just going to be taking and adding some things. If I made this minus 2x, it just moves, but you'll see that there's common shapes that you're looking at here. If I put a minus sign or a negative sign in front of the x, you'll see that it opens down. Or if I put a 2 right here, you'll see that it becomes a little bit skinnier. Or if I make this 0.5, you'll see that it's wider. But there's some common shapes here as long as there's an x squared term. Or if I got rid of this particular x, it moves a little bit. But generally what you're seeing is quadratic functions kind of look like a U shape in a sense, or an A shape if you put a negative in front of here. That's as long as they have a squared. What will be interesting too is if I get rid of the squared, it all of a sudden becomes a line. So if you don't have a squared term, you have a linear function. That's y is equal to mx plus b in standard form. So those are not quadratic functions. So quadratic functions must have a squared like this in the particular function. So back to the lesson. First thing we're going to do here is write each of these following functions in standard form and see if they are. It says then state whether or not the function is quadratic. Well, this function here, there are no brackets and it does have a squared, so it is yes, a quadratic. The next one, if we get rid of the brackets or simplify this particular function, we would have y is equal to 2x plus 6, and there's no squared, there's no x squared, so that means no, it's definitely not a quadratic. And the last one is not in standard form. To put it in standard form, we're going to want to simplify, so x plus 3 squared is x plus 3 times x plus 3, and if we distribute those binomial products, we'll have x squared plus 3x plus 9 minus 9, and this is y is equal to x squared plus 6x, and the 9's cancel out. And this does have a squared term, so it is going to be a yes. Now we're going to look at in the next part of the lesson is just some definitions having to do with quadratic functions. So as you saw when I was using the internet website creating quadratic functions, here's an example of a function that would look quadratic. Now just a few definitions that we're going to look at. The vertex is the highest or lowest point on a quadratic function. So if I was to indicate the vertex here, it would be the point -2 and 9 because that's the coordinates of that point. So this is -2 and 9. The axis of symmetry, what you'll notice is that quadratic functions are symmetrical about the vertex. So the axis of symmetry is a vertical line. It's invisible, but it's an invisible vertical line that passes through the vertex. So that line right there in red, right here, is this axis of symmetry for this quadratic function. And that line is x is equal to -2. So that's an example of that. X-intercepts are where the function crosses or touches, but I'm just going to put crosses here, the x-axis. So our x-intercepts here would be these two green circled points, and those points would be the 2 points -5 and 0, and also 1 and 0. y-intercept. The y-intercept is where the function crosses the y-axis. So this point here in orange is your y-intercept. And so the example there, that point would be the point 0, 5. Two more definitions, domain and range. Domain is all of the possible input values, which is usually x of a function. So for this particular function, it will go, if you look at these arrows, it will go, I promise you, to the right forever and also to the left forever. You can have any input value for this function. So this would be a domain of all real numbers, which can also be written like this, from negative infinity to positive infinity, or symbolically x belongs to the set of all real numbers. So any of those represent a domain of all real numbers. Finally, a range. Range is all of the possible output, which is usually y values of a function. So for this particular function, what you'll notice here is that the highest y value is 9, and it will go down forever from there. So if we're talking about a range for this particular function, it would be everything below and including 9. So that would be y is less than or equal to 9. Or you could write it like this, from negative infinity up to 9 inclusively. And that is your range of this particular function. So 9 is the highest y value, and anything below that could be part of the range. And that is the end of this particular lesson.